All right, this lesson's on the area of trapezoids, and we have one goal for today, and that goal is I can find the area of trapezoids. You can go ahead and pre-rate yourself 1, 2, or 3. Do you know the area formula? Do you know how to use it already? Rate yourself. All right, so recall, we already know this because we already did finding, we learned about trapezoids, just not how to find the area. But a trapezoid is made up of one pair of parallel sides, and those are known as the bases. So if you look here, this is a trapezoid. Base 1 and base 2 are parallel lines, and then the other two sides of the trapezoid are called the legs. If our goal is to find the area, note that we could always just break it up into two triangles and a rectangle. So if you needed to, if you ever forget this formula, you could always draw lines, the heights, the perpendicular lines to the bases, and you could break it into a rectangle and two triangles. However, there's also a formula we can use that will be easier for us to just get started on the problems with. So in order to just find out what the formula is, instead of me just giving it to you, we're going to discover what it is. So if you look here, I have two triangles. Here's one triangle, or sorry, trapezoids. One trapezoid and two trapezoids. One is just a copy and paste of the other, okay? So this is still triangle 1. This is still, I keep calling it triangle, trapezoid 1, and this is trapezoid 2, except for trapezoid 2 has been rotated 180 degrees. Notice that since it's been rotated 180 degrees, this side and this side, okay, it was this side before it got rotated, are the exact same. It's a replica, right? So if we smush those together right there, okay, taking those two sides right there, pushing it together, we now have this figure. Okay, it fits perfectly together. So if you look at what this figure is, this is a parallelogram. And we know how to find the area of the parallelogram. So if we rename these, I'm not going to write on this because it's already labeled here. But once again, this was base 1, which is rotated here to base 1. This is base 2, which is rotated here to base 2. Okay. If you, oops, I didn't highlight enough, base 2. If you look at this now as a parallelogram, we can find the area of this parallelogram. We know the formula for area of a parallelogram is area equals base times height. So I need the length of the base, which is this right here. This length is this plus this, which is base 1 plus base 2. And the height is perpendicular to both of the bases, which is right there, and that is just still the height, okay? So to find the area of this green parallelogram, it's base times height, which the base is base 1 plus base 2. So the parallelogram would be area equals the base times the height, okay? But this was two trapezoids together, right? So that's for two trapezoids. This I just want for one trapezoid. So we divide that by 2. And there's your formula for the area of a trapezoid. Now you can write it like this, the way I have it. Or, remember, dividing by 2 is the same thing as multiplying by 1/2. So you can also do area equals 1/2 base 1 plus base 2 times the height. So either one of these formulas work. When I'm typing it in my calculator, I do this. But when I'm writing it down, I do this. Okay, so let's go ahead and try this. I only have a few examples here because it's pretty easy, right? All right, so find the area of the trapezoid. Area equals 1/2 base 1 plus base 2 times the height. All right, so I'm going to put area equals 1/2 times, I need the bases added up, times the height. The bases are my parallel pieces, so that's this piece and this piece. That's 5 and 11. And then my height is the piece that's perpendicular to both of the bases, so that's 8. Okay, so now I can put that in my calculator, or I can do some mental math. I'm going to do 1/2 of 8, which is 4, and then 4 times 16. That's the mental math that you can do, which is 64 centimeters squared. Now, if you wanted to put it in your calculator, there's multiple ways that you can do it. I'm going to pull my calculator over here just to show you what we can do with that. Get my calculator moving. There she is. Okay, so you can do 5 plus 11, which is 16. 16 times 8, which is 128, and then divide that by 2. So that's just another way of doing it. All right, this one right here, find the area of the trapezoid. So area equals 1/2 base 1 plus base 2 times your height. So my bases are my parallel pieces. Those are 7 and 19. And then my height is perpendicular to those two bases, which is 12. So I'm going to do 7 plus 19, which is 26. 26 times 6. 26 times 6 is 156, okay? Once again, you could do parentheses, 7 plus 19, close parentheses, times 12, enter, 312, divided by 2, enter, and I get 156. 156, centimeters squared. All right, here's the last one in the bunch. Area equals 1/2 of base 1 plus base 2 times height. All right, my bases are my parallel pieces, so this is 13. This right here is 16 plus 9, which is 25, so this is 25. My height connects perpendicular to my two bases, and that is unknown. It's x, right? So I don't know it, so I have to figure it out. If you zoom in here, you have this right triangle, and it is also one of the legs on my right triangle. So I can find it using the Pythagorean theorem. I'm going to do leg squared plus leg squared is equal to hypotenuse squared. That's x squared plus 81 is equal to 225. Subtract 81 from both sides. That's x squared is equal to 144. Square root to solve. You don't have to do plus or minus because this is the height, which is a positive distance. And we get 12 centimeters. So now make sure you don't say, my answer is 12 centimeters. Put 12 in for your height and then put that in your calculator. So I'm going to do 13 plus 25, which is 38, times 12, divided by 2. And I get 228 centimeters squared. These happen to all be centimeters for our lengths. So centimeters squared for our area, that could change to any sort of measurement. All right, now we have 4 more problems. It says find the areas of the figures formed by each set of points. So these aren't necessarily trapezoids. They could be, but they might just be some other figure, okay? All right, so 4 points. So I know it's a quadrilateral, but as of right this red hot second, I don't know what it is. So let's graph it. -1, 5. Oops, that's not, yeah, that is -1, 5. 6, 5. -4, -1. And 7, -1. All right, so I do have parallel lines right here. These two horizontal lines are parallel. And then I have 2 legs. This is a trapezoid. All right, so area of a trapezoid is area equals 1/2 base 1 plus base 2 times the height. So I need the bases. Remember, the bases are my parallel sides of my quadrilateral. So this and this are my bases, base 1 and base 2. It doesn't matter which one's which, but I'm going to count how long those are, how many units. So I have 1, 2, 3, 4, 5, 6, 7. So one of my bases is 7. And then this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one's 11. All right, now I need the height. Remember, the height connects the bases with a perpendicular line. So if I have 2 horizontal lines, a vertical line is going to be perpendicular to that. So I want to connect my 2 bases with a vertical line. Okay, and I could connect it where I did, or I can connect it here, or I can connect it here. I can connect it anywhere, okay, as long as you're connecting your 2 bases with a line perpendicular to both. So this height is 1, 2, 3, 4, 5, 6. So the height is 6. And then now all I have to do is multiply this. So 7 plus 11 is 18. Half of 18 is 9. 9 times 6 is 54 units squared. All right, and I'm going to move on to the next one here. I'm actually going to move this work up from my other problem because I don't want it to be in my way. All right, let's see what this is here. So I have a point at 2, 6, another quadrilateral for sure. 7, 3. Okay. 7, negative 4. And 2, negative 6. All right, looks like another trapezoid. So I have 2 sets of parallel lines. This time those lines are vertical. And then I got 2 legs right here. All right, area equals 1/2 my 2 bases added up times the height. So let's get my 2 bases, which once again are my parallel pieces. This time they're vertical lines. So let's find the area, let's find those distances. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is one of my bases. 1, 2, 3, 4, 5, 6, 7. 7 is one of my other bases. And then the height connects your 2 bases. My 2 bases are vertical lines, so I'm going to use a horizontal line for my height. 1, 2, 3, 4, 5. All right, so now I need to multiply this. So I'm going to do 12 plus 7, which is 19, times 5. Oops, that's divided by 5. 19 times 5, enter, and then divide that by 2, enter, and I get 47.5 units squared. Okay, let's move on to the next one. Trapezoids seem pretty, it's not. As I say, trapezoids seem pretty good here, so I was hoping it was one, but I see that this is a triangle because there's only 3 points. I got 4, 1, negative 2, negative 2, and negative 2, 6. Negative 2, 6. All right, it's a triangle. Connect my 3 pieces. Didn't do a great job connecting them, but I tried. Area equals 1/2 base times height. So I'm going to do area equals 1/2 base times height. Notice I wrote out the formula again because it's been a couple days since we've done triangles, and I want to make sure I'm reviewing those formulas. I already need a base and a height. A base and a height are always perpendicular. So what I'm looking for is a vertical and a horizontal line, or just one of them, and I'll draw the other one in. So here I see a vertical line, so I'm going to use that as my base. I'm going to count it right now. 1, 2, 3, 4, 5, 6, 7, 8. My base is 8. And then my height's perpendicular to that. So my height is going to be a horizontal line. So what I'm going to do is I'm going to draw a horizontal line from the base to the opposite vertex there, the highest the triangle goes. And then I'm going to count that. 1, 2, 3, 4, 5, 6. Okay, so I have area equals 1/2 of 48, which is 24 units squared. All right, the very last one, this is another quadrilateral. We'll see if it's a trapezoid. Negative 4, 0. Negative 2, positive 4. 4, 1. 2, negative 3. Okay. So it doesn't look like a trapezoid. Looks like a parallelogram. Maybe a rectangle. Okay? I could check the slopes on both of the lines to see if it's a rectangle, and then use the Pythagorean theorem to find each and every single hypotenuse, but I feel like there's an easier way for me to do this, and that is make this into a big giant rectangle and then subtract the 3 triangles on the corners. So what I mean by that is I'm going to make a right triangle connecting each of my vertices of my, well, I don't like the way that one looks. I'm going to do a little bit better job. Ugh, that's still not that great. Okay, so I'm just basically making a big giant rectangle here. Okay, so what I'm going to do is I'm going to find the area of this pink rectangle. Then I'm going to get rid of this triangle, rid of this triangle, rid of this triangle, and rid of this triangle. Remember, this triangle and this triangle are the same, and then the other 2 are the same too, okay? All right, so the area of the pink rectangle, so I'm going to say my plan is to area equals the rectangle minus the 4 triangles, okay? All right, so I'm going to do area equals, and then I'm going to do just the rectangle. So the rectangle has 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1, 2, 3, 4, 5, 6, 7, 7. Okay, so that is 56 units squared. But now I'm going to get rid of each of the triangles. So this triangle, 1, 2, 3, 4, 5, 6, 7. Oops. 1, 2, 3, 1, 2, 3, 4. So that triangle is area equals 1/2, 3 times 4. So that's 12, half of 12 is 6. So this is 6 units squared. So this is 6 units squared. And if you look, this is not a 4 by 3, like I said. 1, 2, 3, 4, 5, 6. 1, 2, 3. So, oh, I counted that one wrong. That's why. I was going to say they're not the same, but I counted that triangle wrong. So let's go back and get it. I went too fast. All right, let me bring that back. Let's try it again. They are the same triangle. I was just looking from those green dots. But that's wrong. Get that 6 units out of there. Oh, no. Okay. All right, so this is 4, and then this is 1, 2, 3, 4. I stopped counting there, but I need to go to this vertex, 5, 6. So this is 6. So I have 1/2, 4 times 6. Half of 24 is 12 units squared. This is 12 units squared. This is also a 6 by 4. 1, 2, 3. It's a 6 by 3. I counted my dots. Man, I'm struggling on this problem, apparently. Let's try that again. 1, 2, 3. 1, 2, 3. Good thing I'm checking instead of just assuming. So they're 3 by 6s, not 4 by 6s. Half of 18 is 9. Well, at least I'm double checking. Otherwise, and I'm going to double check on the other ones too, because I'm not going to just assume that I'm doing right. 9 units squared and 9 units squared. And then let's check this one. 1, 2. 1, 2, 3, 4. 4 by 2. And this should be a 1, 2, 3, 4. 4 by 2. Let's double check this. This is 7. This is 8. Okay, I did that correct. All right, so a 4 by 2 and a 4 by 2. Area equals 1/2, 4 by 2. Half of 8 is 4 units squared. So this is 4 units squared and 4 units squared. So I'm going to have to do the 56 units squared minus the 4 triangles. The 4 triangles were 4, 4, 9, and 9. Or you can do minus 8 and minus 16. Okay? So 56 minus 8 minus 18. And I think I even called that 16. I'm having a bad mental math day. So that is 30 units squared. My goodness. All right, how do you feel about that? Did I mess you up on the last one? Well, it's not a trapezoid, and our goal today is find the area of a trapezoid. So go ahead and re-rate yourself. 1, 2, or 3. As a reminder, trapezoids could be in the coordinate plane or just given a picture of it. All right, that's it.